Welcome back to Dan on Dev. Today we are continuing the Why All AppSec Products Suck series with Why All SCA Products Suck. This is going to be a dive into the different categories of the application security product space. So today, again, Why All SCA Products Suck. We're going to be looking at all these tools, and just as a reminder, if you haven't watched the previous episodes, this is part of a series where we're going to go through all the different categories. The goal is not necessarily to beat up on the individual product categories. What I want to do is illuminate what these tools are good at and what they are not good at. No one tool will solve all of your problems. And I'm going to keep repeating this. There is no one tool that will solve all your problems. You need to understand the strengths and weaknesses of each of these products, each of the product categories, and then even, there's granularity within that. Each of the product categories have different products that are going to be good in some areas and weaker in others. So it gets really nuanced, but I want to kind of keep it broad on just the categories themselves. If you understand what the tools do well and not so well, then you can pick the right tools for the job. And I've said here before, if you are only allowed to pick one tool and you need to build a house, that's quite a task. You're not really going to be successful in that model. So that's really what I'm trying to focus on here is let's look at these different categories of products and let's figure out what they are good at and not so good at. So today we've already covered in the second episode was the static analysis tools, the DAS tools. Then we did IAST. Now we're finally on SCA. This will be the last automated attacking or testing tool. Then we got some defensive, and then we'll talk about manual. But we're kind of working our way through this series. So really, let's do a 101 on what SCA is. That's software composite analysis. You can also think about it as a, was it bill of labels or whatever? You're looking at what all of the components that you're using. These days, people do not just build from scratch. Maybe with some C++ coders, they may still do a lot of things from scratch. But even then, you're going to be pulling in DLLs or whatever to do certain bits of work because it doesn't make sense to write all the code yourself. As we start getting into kind of modern web development, it's gotten fairly extreme. People are taking massive libraries, these big, huge, massive libraries that do all sorts of work. Think about a React framework, which has a whole bunch of client-side work that it'll do, but also there's, server-side React, and you can actually run the whole darn thing in React. The amount of libraries that people bring in, sometimes they'll bring in a massive library for one little function. And so what you want to be able to do is look at what am I using? What are all these third-party libraries that I'm using? And those libraries could use libraries that would use libraries. So it gets pretty deep at times. So what libraries am I introducing into my code by way of including these resources? SCA, that's its job, is to go and look at all of the compliance for security fixes as well as licensing. So it'll check the licensing of each library as well to make sure you're not accidentally including, let's say, open source libraries that are like GPL, which are more, they're going to kind of infect your licensing, if you will. But you want to look at make sure you're using compatible licensing for your use case. So it'll cover that as well. Not necessarily a security thing, but it's a software development thing that you really need to be tracking, and it's important. So SCA is going to do that. What it's basically going to do is this little robot is basically going to go through and inventory everything. And it's going to end up finding out what you're using. And it'll actually tell you, okay, you've got this package and it's got, this vuln associated with it. So it'll kind of break down a list of all of the different problems that you've introduced by way of including libraries into your code. And it'll tell you which libraries you have and what vulnerabilities are associated with them. So that's a massive help. And so that's very useful. But why does it suck? Well, one of the issues is that it doesn't even look at your custom code. It's only looking at the libraries, really. It's only looking at the libraries that you're including to help your code then do the rest of its work. So it doesn't look at it. I would generally argue that your custom code is most likely to contain the most vulns, because a lot of these third-party libraries, they have at least some level of community monitoring and code review that happens somewhat, okay? But there is some level of other people watching and looking for fixes, and you have also other attackers looking in the code and trying to find issues that then get reported, which then get fixed. So there's a little bit of review that goes on in those, whereas your own code, you're the only one that's going to really be able to see it and review it and make fixes. So that's an issue. Also, the business logic flaws, they're only going to be in your code by and large. Your own custom code is going to be the problem, is where your business logic flaws will land. And then the other issue is there are a lot of false positives from when as I mentioned earlier, you may grab a library that has thousands of functions in it, but you grabbed it for one thing. Okay, we had this issue. We used Boost regex. We used the Boost library for the regex function, but Boost has a whole bunch of other stuff that it has. We just happen to like its regex library. But an SCA product would see that we're including Boost, and any other issues with Boost would get reported, even though we're only using it for the one area and only ever executed the one area, and so we're not actually going to be vulnerable on the other areas because they're never actually getting executed. So this is kind of a problem with SCA, is they struggle to understand what parts of a package you're actually using. And so sometimes you're going to get flagged for something that is never actually going to be actionable. Nobody ever could actually exploit it on your code, but it's going to show up in your report, and you're going to be kind of obligated to fix it. So that false positive from that scenario is kind of annoying. It's also still early to understand how effective these solutions are, because according to Snyk, they say 80% of the vulnerabilities are introduced via these transitive dependencies, these third-party dependencies. Whereas like somebody like Contrast, who I mentioned earlier, they create an IAST product. That's one of the other categories we've already covered. They say that only 7% are from the libraries. Who's to be believed? I don't know who's correct. This chart is actually pretty illuminating in that you'll see they'll say, okay, it is the tip of the iceberg is your custom code. This is a great analogy, and this is actually very accurate. And you'll see that there's the slice of your custom code here on top, up here, and then the middle area is your active libraries, the third-party stuff you're actually using. And then you have this other 42%. And again, this is according to Contrast, so that's their numbers. But just take it for a grain of, with a grain of salt, but let's look at this as a concept here. 42% of the libraries are actually inactive, not actually being used. So they don't actually matter. So if you look at the vulnerable code, there's that 7% here, the vulnerable code from the libraries, they're claiming that's only 7%, and that 93% of the vulns are actually coming from your custom code, because that's where the actual custom work is, as I mentioned earlier. So, how effective this is, I don't know. It is useful, and I totally firmly believe and recommend using an SCA solution, but I would definitely hesitate to say that's the only. Again, you need to know what the products can do and not do, because it's going to be limited on what it can do all by itself. Another thing about why now let's flip. Another reason why it rocks is that generally it's very easy to run. You can point at your GitHub repos, it'll run, it'll tell you what the issues are, it'll show you which libraries you're using that are outdated and which ones need to be upgraded. And that's generally easy to do. Once in a while, you'll have to upgrade and it'll break things. That's one downside of using third-party libraries, that may change their behavior. And so you have to be careful when you're upgrading to the newest version of a library. But it's actually pretty easy. And then The other thing is, this can really be improved dramatically when paired up with an IAST, a RASP, a DAST. I like pairing up a DAST and an SCA to kind of get both coverage, or an IAST as well. You can kind of, if you marry those two up, now you have something looking at your custom code, and when looking at your packages, you kind of get a pretty good coverage. The license compliance is also important. You need to do it for legal reasons, so that's very useful. So that's what ends up being really good about the SCA products. Again, I recommend using them, but not alone. I don't think they solve everything on their own, but still very useful, very important to do. So anyway, that's this next episode. The next episode, we're going to switch over to defensive products. We're going to be talking about the web application firewalls. If you want to continue following, please check our website, click on the follow link on this channel, and join us for the next episode as we get into the defensive products. Thank you very much. This is Dev on Down.